All right, so let's talk some more about checking error assumptions. Okay, so as a reminder, what are the assumptions for linear regression with respect to the errors, to epsilon? It's constant variance, normality, and independence. And so we've talked about constant variance already. Now let's talk about checking normality. So hypothesis tests and confidence intervals, they rely on the errors being normally distributed. And we can check the distribution of the residuals using a ggplot and a histogram. And this can give us some idea of whether this assumption is violated. So what's a ggplot? So a ggplot is where you plot the sorted residuals. So you sort residuals from smallest to largest, and then you plot them against this normal quantiles for each of the from I to 1 from 1 to n. So through each of the observations in your data set. And so here's how you would do this in R. So for example, if I was fitting a model here, like a linear model, I would first fit that model and pull out the residuals using the resid function. And so I'm going to call that E. And then the next step is I'm going to sort those residuals. And so there's a function in R called order, which will give you the indices in order according to a certain, the variable that you give it. And so what this does is it takes the vector E, which are the residuals, and then the brackets here are saying that we want to select the specific indices that we're going to specify. And so in this case, we're specifying all of the indices in this vector from 1 to n. So there are n indices here. So we're selecting them from 1 to n, but we want to do it in a certain order. So for example, if the smallest was like -3, and that was the fifth residual that popped up based on the order of this data frame, then that -3 would be first. So if we did order E, then 5, the index 5 would be the first one listed. And when we output this after we've sorted, that value itself will be the one that gets output. So that's what this does. This is just sorting our vector of residuals. Okay. And then this is going to calculate n. And so to plug into this function here, we have to be able to calculate n. And then in order to calculate what we're going to use on the x-axis here, we use the qnorm function. So norm here refers to the normal distribution. Q refers to quantile. And in this case, we're going to go from 1 to n over n plus 1, because we're indexing, this I here is going from 1 to n, and we're dividing by n plus 1. Okay, so we've got E, our residuals, and we've got them sorted, and then we have Q, what we're going to stick on the x-axis of this plot. So I'm just putting these into a data frame that has 2 columns, it has n rows, and now I can plot it. So this is how you would plot this by hand. You would take that data frame, on the x-axis, you're going to plot those theoretical values, and on the y-axis, you're going to plot the actual residual values. And you get this kind of plot. Here we have these kind of dots that follow. And basically what you want to see is that these dots follow a straight line, which would indicate that the residuals here follow kind of what you would expect from a normal from normal quantiles from the normal distribution. And so there's actually a little bit of an easier way to do this instead of having to calculate those all by hand. If you just have the vector of residuals, ggplot has some built-in functions that will actually do all this for you, so you don't have to actually plug in to that qnorm function. But it's good to sort of understand the underworking of how this works. So these two plots, the dots are going to be exactly the same. The only extra part here is ggplot has this nice function geomqq line, which will add a nice line to this plot, which makes it a little bit easier to sort of see if these points deviate from a line. And so what this looks like to me is, it looks like, yes, these points do deviate from the line, especially kind of up here in the tails and down here. But even, around here, that it's not, this does not look like these residuals are sort of perfectly normal. And we can also look at a histogram of these residuals. So, just to step through quickly what's happening here. So first, I want to note that instead of using X and Y in the AES or the aesthetic part of ggplot, we're going to use the sample equals. And that's just what's necessary in order to use the QQ function subsequently. So it's going to be sample equals, and then you're going to put the name of the variable that contains your residuals in your data frame. So in this case, we've got a data frame D. The name of our residual variable is E, so that's going to be the sample. And then GMQQ is what's actually putting these points down. So if we just ran these top two lines, we would get exactly the same plot as I got when I plotted this by hand. And then this GMQQ line draws that nice reference line for us so we can see, do these points really follow on the line we would expect them to? Okay, so the other way that we can sort of look at normality is by plotting a histogram. And so here I'm still plotting, I'm still doing a ggplot, but now instead of using sample, I'm back to my normal X here, because now I'm just plotting a histogram of these residuals. And so that's why I use this geom histogram. And looking at this histogram, if we were expecting this to be normally distributed, we'd expect kind of a bell-shaped curve. This looks a little bit skewed to me. It's hard to tell in general because this is a pretty small data set, but that's still kind of worth noting that potentially the normality assumption is a bit violated here. So let's generate a normal one so that you can kind of get an idea for what this looks like when it's done correctly, or when you have normally distributed residuals. And so to do that, first I'm setting a seed here, just because I'm doing a random process. And then I'm using this rnorm function, and what that does is it generates a random normal variable, and I'm going to generate 1,000 of those. And so you've seen this in previous lectures here. So I'm generating 1,000 random normal variables. By default, these are going to have a mean of 0 and a standard deviation of 1. I've ordered them here. I actually don't have to, because ggplot, if I use the built-in functions, you don't have to order them first. It'll do it for you. If you're doing it by hand, of course, you do have to go ahead and order it. And then I'm just sticking these in a data frame called D. And I'm sticking them in a data frame because in order to use ggplot, you need to have your data in a data frame. Okay, so using that code, I'm going to set this. Remember that we need to have the sample equals E. And that's because that's just what the QQ functions require, that you use the sample parameter there. And then I do my GMQQ to draw the dots and my GMQQ line to draw the reference line. And so this is what a very, very good QQ plot looks like, where essentially these points fall just right on the line. In the tails, there's a little bit of a deviation, and that's really just by kind of random chance. But typically, in this case, and we know these points here, we know they're truly randomly normally distributed because we generated them to be normally distributed. And so we would expect to see exactly this, where they kind of follow the line. So this is a very, very good QQ plot. And just so you can see kind of what a histogram that's good and normal looks like, this is what that histogram looks like of that same generated data. And so it's bell-shaped. It's got the center here where you would expect it. And it seems pretty symmetric on either side. So this is kind of a good histogram. If you're looking at a histogram of residuals and it looks like this, then you know you're doing pretty well. Here's a histogram just so you can see what it looks like if you have some right skewed data. And so this data is skewed right. And the way I've generated that is I've taken the residuals that I had generated from my normal distribution, and basically all of the ones that are greater than 0, so all the ones on this side of 0, I multiplied by 5, so that so all the ones over here I multiplied by 5, and then all of the ones to the left of 0 stayed the same, and I also actually just kept the additional ones as well. So basically what I did was I added this like big tail over here. So I concatenated. What this C does is it basically will concatenate two vectors. And so I took my normally distributed data here, and I concatenated on any of the values that were greater than 0. I multiplied by 5, and I end up with this nice long tail. Okay, so this is some right skewed data. And when I plot it, this is what it looks like. So if you see something like this, this is not normally distributed. This is a skewed relationship. And this is what that would look like on a QQ plot. So when I look at this, this right skewed data, it looks like, oh wow, I can tell this is right skewed because up here, I end up deviating very dramatically from the line that I'm hoping I would be on if this was really normally distributed. And you can also have left skewed data, so on the opposite side, which I generate that by just, instead of multiplying the values that are greater than 0, I multiply those less than 0 by 5, and so I end up with all these extra pieces in this negative space over here. And so now I've got this nice left skewed data set. And when I plot that, this is what it looks like. So this is what a histogram of left skewed data looks like. And if I look at a QQ plot of left skewed data, this is what I would see. So basically, I would expect to see that the points will deviate from the line kind of underneath here in this way. And so I'm doing this just to give you a sense of kind of, when you look at a QQ plot, you can kind of get some sense for how you expect the data to be skewed, so that you can have a sense of kind of what you might need to do to fix this problem, which we'll talk about in just a little bit. So what I want you to do is I want you to generate some fake data under the following scenarios using the code that I have provided, along with, in 2 of the scenarios, I have not provided the code, but I give you some hints on how you can do it. And so I want you to generate some data, and I want you to plot a QQ plot as well as a histogram for each of these, and then I want you to describe what you see. And this is going to be hopefully a helpful exercise so that you can sort of practice when you're looking at these plots to be able to interpret them. So I want you to look at some left skewed data, some right skewed data generated under a log normal distribution. And so there's a function called RLNorm that can generate some random log normal values. And then also data generated under a t distribution with 2 degrees of freedom. And so that's going to be, you'll use the RT function to do that. So take a couple minutes to work on this, and then you can come back and keep going.